reaction is there, it's again a reversible reaction, and it is indicated by a color change, just like copper sulfate and the hydrated copper sulfate. Okay, the question says the nitrogen dioxide and nitrogen tetroxide exist together in equilibrium. Okay, we have used a gas syringe that contain a mixture of both. The mixture is brown in color. Okay, the plunger is pulled out to reduce the pressure. Now the pressure is reduced, the color get darker. Why? When the mixture is reduced in the mixture. Okay, okay. So why does this happen? The plunger is okay. Okay. And what about the reduction in pressure? Okay. Relate pressure with equilibria. Pressure with equilibria. Reduce pressure means decreased pressure. When the pressure is decreased, how does this equilibria react? Equilibria would move towards, exactly, move towards more moles. Where are more moles? Nitrogen dioxide. So the equilibria would move towards left, which has nitrogen dioxide, which is brown in color. That's why the color gets darker. Okay, I'm again saying this. When the pressure is reduced, the equilibria would shift towards the left because that side had the lesser moles of gas. Since there is more nitrogen dioxide, so the mixture gets darker in color. Okay? Okay. Let me move to the next question. Okay, next part of this is a sealed tube containing a mixture of nitrogen dioxide and nitrogen tetroxide at room temperature is plunged into water at 0 degrees Celsius. Explain, okay, the reaction mixture changes from brown to pale yellow. Now the color gets lighter. It means the reaction is moving towards, okay, let's get back to it. The reaction would move towards the right side. Okay, decreasing the pressure moves the reaction towards the right side. Would it be endothermic or exothermic? Endothermic. Good. So how would you explain it? Don't. Okay. Wait. Since since it's incorrect, let's go back to the main concept. Okay. Where is that part? Temperature. Okay. Read it. When the temperature increases, the endothermic would move in the forward direction. Okay. So here is a decrease in temperature. The temperature is 0 degrees Celsius. So yes, the reaction would move in the forward direction. It's correct. It's correct. But it won't be endothermic. It would be exothermic. Let me write it for you here. Temperature decrease. Exothermic means forward direction and endothermic means reverse. Okay? Since the temperature is decreased, so the reaction is moving in forward direction. That's why it's getting light in color. So this reaction is exothermic. Okay, and how do we explain it? So, a decrease in temperature shifts the equilibrium towards right. It means that the reaction is exothermic. The mixture gets lighter. Oh, am I writing? Oh, wait. Is the answer erased for this one part? Wait, I'm supposed to write answer over here, not there. Answer should be here. The mixture gets lighter in color or gets pale yellow. Clear? Okay, in the forward reaction, a bond is formed between the two nitrogen dioxide. Explain whether this information support your answer. Do you think this is true? Yes, it's true. Yes, it's true. It happens. Look, there are two molecules which are bonding together. It's true. But let's explain. Why do you think it's true? First of all, we have discussed that decreasing the temperature moves the reaction in forward direction. And here there is a formation of bond. So bond making is which process? Which process? Exo. Wait. Bond making is exothermic process. Okay, let's practice more. Um, okay. Again, a question has been repeated. Two features of dynamic equilibrium. What are the two features of dynamic equilibrium? Concentration of reactants must be equal to the concentration of products. Okay. Of. Okay. Yes, correct. Equal rate of forward and reverse reaction. Okay. Next part. How would a decrease in decrease in temperature affects the amount of methanol in the equilibrium? Keep in mind that this is exothermic process and you have decreased the temperature. Okay. So would methanol increase or decrease? Exothermic, decrease in pressure. Oh, sorry, decrease in temperature. Okay, wait. Let's go back. Wait. The temperature is decreased. Wait. I shall give you this screenshot. Just give me a minute. I'm giving you the screenshot so that you can keep it in front of you. Okay, now you have to look at this image before answering. Okay, the question is, the reaction is already exothermic, is indicated above, is minus 91. Minus sign means is exothermic. Now you have decreased the temperature. If the temperature is decreased, the exothermic reaction would move in. Wait, am I saying pressure again? Okay, sorry. A decrease in temperature, move forward, so there would be more methanol. And how do we explain it? Yes, there would be more methanol because this reaction is exothermic and low temperature favors the forward reaction. Decrease in temperature favors the forward reaction. Okay. How would increase in pressure affect it? Increased pressure mean towards the lesser moles. So would methanol increase or decrease? Wait. Which side has the lesser moles? Left or right? Right. So the reaction would be in right direction. Would methanol be more or less? More. Increasing the pressure moves the reaction towards lesser moles. Okay? Uh, let's move to this next part. Okay, methanol is converted into methanol and the catalyst uses iron oxide. Temperature is 250. Methanol and water are the two only products. Write the equation. How? Okay, they have given you the products. They have given you the reactant. Can you write the equation? Let's say methanol, CH3OH. What is reacted over it? We reacted with it. Oxygen gives two products. And what are those two products? Methanol, which formula is given, H2CO, and water. Yes, we can write it. Is this balanced? Okay, check one more time. I don't think so. It's balanced. I don't know why I feel it's not correct. Why do I have a feeling? Though it seems to be correct. Yeah, oxygen are three on the left side. How should we balance it? Okay. Uh, okay, carbon is balanced. Let's move to oxygen. What should we do? Okay, let's say if we write 2 over here and 2 over here, the balance would be out. So let's not change this one. Let's change hydrogen. So there are 4 hydrogen. Let's make them more. Let's put 2 over here. Now we have 2 carbon. Let's put 2 over here. How many hydrogen? 3 and 1 4. 4 into 2 is 8. So there are 4 over here and 4 over here. There are 8 now. Okay. How many oxygen are now available? 2 here and 2 here. 4. Two here and two here. Four. It's balanced now. Okay. What is meant by term catalyst? Okay. It speeds up the rate of reaction. What's the second important point of catalyst? Without being used up. Used up. Speed up rate of reaction. Okay. The other thing that you can write for without being used up is uh, it remains unchanged during a chemical reaction. That this one is more appropriate explanation according to chemistry. Okay. Or you can also write it remains chemically unchanged during the reaction, because it can physically change, but chemically it would remain same. Okay, how does a catalyst work? Yesterday or the day before yesterday we discussed it. Gives what? Alternative pathway for the reaction to occur. Okay, and how does it do? What's its effect on the enthalpy? Remember the energy profile diagram? It lowers the, yeah, lowers the activation energy. Okay, here you go for 2 marks. Okay, what is the chemical composition combustion for methanol? It's a complete combustion. Methanol is CH3OH already given, so it would burn out in oxygen and form. What are the products of combustion? They're always same: carbon dioxide and water. And is this balanced? Okay, let's do it then. Let's put two over here. Okay, two over here and two over here. Will it be balanced? No. Okay, four. Okay, now carbon and hydrogen are balanced. What about oxygen? Oxygen are eight on this side. Is it so? Okay, three in front of oxygen. Now it's balanced. What is the catalyst that we use in Haber's process in the preparation of? Okay, let's discuss Haber's process in detail now, because you would need this explanation. Let's talk about Haber's process. Okay, Haber's process is used extensively for the preparation or for the manufacturing of different products. Basically, nitrogen reacts with hydrogen under special conditions to make ammonia, and those special conditions are catalysts, which is iron. Okay, the temperature is high and the pressure, okay, temperature is not that much high, but the pressure is really high. The temperature is, we have already discussed, I guess. I've given you somewhere in the question. So it's okay, pressure is 450 for this one. No, temperature is 450 and pressure is 200. Pressure is 200 atmospheric pressure. Okay, from where this nitrogen is coming? We get this nitrogen from air by fractional distillation. Okay, we can also get hydrogen from the air, but the concentration of hydrogen is really less in the atmosphere. Your atmosphere contains 78% nitrogen, but only a very little fraction of hydrogen. So we need to get hydrogen from some other source, and that another source is catalytic cracking. Okay, the catalytic cracking Remember, is if it results in the formation of a smaller alkane and alkene, so it can give us the hydrogen. So we get it from the catalytic cracking. Hydrogen. Because there is one question related to this, and I want to discuss the question with you. Let me check which question was there. The question is, what are the raw materials for, oh, okay. From where do we get nitrogen and hydrogen? Nitrogen we get from air, and hydrogen from cracking of alkanes. Good. So if we talk about the raw material is air and raw material is hydrocarbon. Okay. What is the catalyst that we have used? Iron. Which temperature have we used? 450. What pressure have we used? 200 atmospheric pressure. Okay. What change can you make to this experiment to increase the yield of ammonia? Okay, this reaction is exothermic. Let's say this is an exothermic reaction. What would you do to increase the yield? Lower the temperature, simple. For exothermic processes, by lowering the temperature, we can increase the yield, right? So we can just lower the temperature. Okay, let me check the other question for this. The equation is given. Calculate the maximum moles that you can do. I know. Okay, there is one question given for this one. Let me just copy it because another product is given which is similar to ammonia. They have used the similar method. Okay, N at 3, NH3, NH3 is another company. What? Okay, bless you. NH3 is another company that manufactures ammonia using the same reaction and amorphous but using different conditions. Okay, it uses a higher temperature and higher pressure. Predict the rate of reaction on the equilibrium by changing the temperature. What if those are changing the pressure? Okay, or temperature. First of all, let's talk about temperature. If they increase the temperature, what would be effect on the general rate of reaction? It would increase. Correct? Generally, we think that. But since, let's consider it's an exothermic process, what would be effect on equilibria? It's an exothermic process and we are increasing the temperature. What would be effect on equilibria? Increasing the reaction of exothermic process shifts the equilibrium towards, wait, increasing the temperature of exothermic processes backward. It shifts the equilibrium towards left. Predict the effect of by changing the pressure used by NH3. Okay, NH3 has increased the pressure. So let's move to the balanced chemical equation. Oh wait, there is no 2 over here. Okay, when we increase the pressure, increasing the pressure moves the reaction where there are lesser moles. So it would move towards Right. So it would move toward right. And how would we justify our prediction? By giving an explanation with respect to moles. Since there are lesser moles at the right, so increasing the pressure would move the equilibrium towards right, which has lesser moles or fewer moles. Okay, let's move to another question. Okay, I'm giving you a question. Take 2 to 3 minutes to think on it and then answer me. Okay, I'm sending you in chat as well so that you can have a clear image because the size, let me just reduce the size.